video, I'm going to be modeling for you how to assess reasonableness when you solve a word problem. So reasonableness is all about how much your answer or your solution or your idea makes sense given the numbers and the operations that you were supposed to use. So when we assess reasonableness, we solve the problem with the actual numbers that are in the story. Then we solve it again, but we use estimation. We use numbers that we've estimated. And so this step, even though it sounds like you're doing double the work, it's simpler because you've already done it once and you're using easier numbers. And then finally you compare your actual solution with your estimated solution, and if they're close to each other, then you can say that your solution was reasonable. If they are very far apart, then you need to rethink or rework what you had chosen the first time. So I'm going to do two examples here for you. This first one here is on Wednesday, the cafeteria sold 643 drinks. They sold 409 cartons of chocolate milk and 128 cartons of white milk. The rest of the drinks they sold were cartons of juice. How many cartons of juice did they sell on Wednesday? So I always like to kind of draw a visual of just what's going on. So here I'm visualizing this is all of the drinks that they sold. And I know that it's a total of 643 drinks for all of them. And let's just say, there's 3 different kinds of drinks that they sold. And so this amount here was the 409 chocolate. And this was the 128 white milk. And then this is the juice. And this is our unknown. We don't know how much juice it was. So here, I need to take away the chocolate milk and the white milk to see how much juice is left. So what I'm going to do is I could do this in a variety of ways. I could put the chocolate and white milk together and then subtract it, or I could subtract the chocolate, subtract the white milk, and have the juice left over. Either one will work. It's the same amount of steps. So I'm just going to go ahead and do 643, and I'm going to subtract the chocolate milk. So that's minus 409. Now I see here that I need to ungroup. If you are not comfortable solving in the equation with the standard algorithm, go ahead and use a strategy, a visual, whether it's expanded form or a drawing method. Either one will work. So here I'm going to ungroup a 10, and I'm going to give it to the ones place. So now I'm going to do 13 minus 9 is 4. Now I can subtract my tens, and I have 3, and then subtract my hundreds, which is 2. So now this leaves me with white milk and juice still. So now I need to subtract my white milk from that. So I'm going to subtract 128 white milks from this, and that's going to leave me then with what is left of the juice. So here I need to subtract my ones, and I see that I need to ungroup again because I can't do 4 minus 18, so I'm going to ungroup, take a 10 away, and move it to the ones place. So now I have 14 tens, so I have 6 tens left when I do my subtraction. 2 minus 2 would be 0, and then 2 minus 1 would be 1. So I have 106 left after subtracting the chocolate and white milk, which means I have 106 juice. 106 juice drinks. So here I have solved with my actual numbers. Now I'm going to do the same step, but I'm going to use estimation. There are 3 different styles of estimation that we're going to use in 3rd grade. Rounding we did at the beginning of the year. We'll also be learning friendly and compatible numbers, and then front-end estimation. If you need to be reminded about rounding, you should refer back to that rounding video, and then we'll also have videos on compatible friendly numbers and front-end estimation. Today I'm just going to use rounding because it is kind of the most precise, and the others can be related to rounding as well. So here I'm just going to say, okay, so my original, I'm going to use the same steps, but I'm just going to use rounded numbers. It's a little easier to work with. So 643 I'm going to round to 640. And I'm going to subtract my chocolate milk, which is about 410 when I round that to the nearest 10. So it's less work because now I don't have any ones to worry about. So 230 once I subtract my chocolate milks. Now I'm going to subtract 130 because that's about how many white milks we have. And here I have 100 drinks left. So now I need to do my 3rd step of comparing. My estimate shows me that I have about 100 juice was sold. My actual told me 106 juices were sold. So when I compare these, those are very close to each other. So I'm going to say that yes, this solution was reasonable. Let me go ahead and do one other example here. Ahmad has saved $40. He would like to buy a video game for $24 and a new backpack for $27. How much more money does Ahmad need to save to buy both items? So my visual for this is, here's Ahmad with his $40. This is where he is, and he needs to get over here with this amount of money so that he can get the backpack and the video game. So I'm trying to figure out the distance between where he is to where he wants to be with his money. So the question is, I actually first don't know this either. So this is my first question I need to answer. Then once I have that, I can solve this question. So first, let me work on where he wants to be. Well, he wants enough money to get the game and the new backpack. So that's $24 plus $27. So if I add those together, that's going to tell me the amount of money he wants to be at. So I can either solve it in my equation if I'm comfortable with that. If not, totally fine to draw a picture here of 2 10s and 4 1s, 2 10s and 7 1s, and join them together. So I'm going to go ahead and work on that in my equation here. I'm going to make a new 10 for 11. 7 plus 4 is 11. Now I'm going to add my 10s, $51. Okay, so this is $51 is where he wants to be, and this is where he is. So now I need to figure out the difference here. So I can either subtract them to find the difference between where he is and where he wants to be, and that would leave me with $11. Or I can count on and say 40 and 10 more is 50, and 1 more is 51. 10 and 1 more is 11. So here I am with my actual numbers. I'm saying he needs $11. I'm going to do that same work with my estimated numbers. And again, it might seem like a lot of work, but you already have done the thinking and you're actually using easier numbers, so it's really not that much more. So here I'm going to do right next to it. I like to do it right next to it so I know what I'm doing. 24 would be rounded to 20, and I'm going to add that to about $30 for the backpack. So it's about $50 that he needs for his purchases. And now I'm going to find the difference between where he wants to be. So here's 50. 40 is already rounded to the nearest 10. So when I find the difference here between about how much money he needs and about how much money he has, I see that there's a difference of about $10. And when I compare my actual amount he needs with my estimated amount, it's only different by 1. So that is very reasonable. So keep that in mind when you're assessing reasonableness, or how accurate or how meaningful your solution is. Solve it first with the actual numbers. Solve it again, but with easier estimated numbers, and then compare them. And if your actual and your estimation is close to each other, then you know that you have been pretty reasonable and have thought through that.